Hey there, advanced math people. Fellas, this should go quicker. Sorry on the last one, how long that went, but with a lot of that early stuff out of the way, hopefully the law of cosines goes a lot faster for us. Notice this one needed the side, 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 or side, angle, side. Law of sines was angle, side, angle, 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 side, or side, side, angle. Okay, Heron's, that's another area formula that we're going to use. If you have one of those two rules right there, you can use it. So side, 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 angle, side, that is the law of cosines. That formula is right here. Okay? So if you're looking for A, B, or C, notice one more step is needed, and that is the square root. So a lot of times I like to think of that as, okay, I'm just going to write the formula like this. A is the square root of all that. Or if I'm looking for B, it's the square root of all that. If I'm looking for C, it's the square root of all that. Okay? So you can take away or rewrite those. Notice if you're looking for C, the only time C shows up on this side is in the angle. It can't show up here because those are side lengths. So it's a squared plus b squared, kind of like Pythagorean theorem, minus 2ab cosine of the angle, opposite the one you're looking for. So a squared plus b squared minus 2ab cosine c. So notice the other two sides have to be known and then the included angle. So you have to know A. If you're looking for side B, you have to know A, C, and then the angle B, side, angle, side. So if you have side, angle, side, you're going to be using the standard form. If you're looking for an angle first, that means you have side, side, side. You're going to be using alternative form. Now remember, A is going to equal, cosine of A equals this. That means A equals the inverse cosine of B squared plus C squared minus A squared over 2BC. Okay, and that's just solving this side for the cosine B. So you have to minus the B minus the C. Do a lot of work with that. Okay, so if you're looking, if you know A, B, and C, and you want to find this angle, you're going to take B squared plus C squared, the two sides opposite it, minus the side opposite the the two sides adjacent to the angle, the two sides making the angle, b squared plus c squared, minus the side that is opposite the angle, divided by 2 times bc, going back to the adjacent, the ones that form it. So if you're looking for b, that would be the inverse cosine of a squared plus c squared minus b squared, b and b, all over 2ac. If you're looking for C, that's going to be the inverse cosine of A squared plus B squared minus C squared over 2AB. Okay, so find the three angles of the triangle shown in figure 1311. Here's 1311. Notice side, side, side. So we have to use the alternative form. So let's say I want to find angle A first. Well, angle A is going to be the inverse cosine, using this, of b squared and c squared, so this is b, so 19 squared plus 14 squared, minus the side opposite, minus 8 squared, all over 2 times 19 times 14. Okay, a lot of that can go in your calculator just as it is. Make sure you're doing the top and bottom parts independently. So I'm just going to do another parenthesis to get the top part together, 19 squared plus 14 squared minus 8 squared. Okay, so there's my top, divided by, again, bottom, start a parenthesis, 2 times 19 times 14. So close the bottom. So I have a parenthesis for the top, a parenthesis for the bottom, and a final parenthesis to close the inverse cosine. And we get 22 degrees. Okay, so you can continue to do this for each one. Now, you do have a given. You can use, we're going to call it 22.1 degrees. You can use the law of sines now if you want to. You could say 8 over the sine of 22.1 equals 19 over the sine of b. I don't think it's that bad to just rearrange things. If I want b, I'm just going to do the inverse cosine of 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14. Especially if I already have it in my calculator. I'm going to go second, enter, bring it up here, change some of these numbers around. That's an 8 squared 8 squared plus 14 squared minus, I have to insert there, 19 squared over 2 times 8. So 116.8. And then I'll take 180 minus A minus B to get my third side. That's C. So 180 minus 116.8 minus 22.1. So about 41.1. So remember, you can use law of cosines twice. After the first one, you can use the law of sines, and then just 180 minus those two to get those two angles. Okay, find the three angles of the triangle shown in the figure. Well, okay, I didn't change that wording. Sorry, there we go. Find the three angles. We already have an angle. So here we have side angle side. That means we're going to be using this formula here. So I'm looking for A. A is going to be the square root of B squared plus C squared minus 2 times B times C times the cosine of 25. That is the cosine of A right there. Okay. So I want the square root of 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 25. And we get 5.4. So you can type it all in just like that. Okay. Now you can use the law of sines if you want to find B and C. So let's try it that way, or you can use the alternate form for the law of cosines. So sine of 25 over 5.4 equals the sine of B. That would be over 9. So B is the inverse sine of 9 sine 25 over 5.4. $44.8. So now you have those two. You can figure out what the last one is, 110.2. Okay, so there's the law of cosines. Heron's formula, this is the area formula if you have side, side, side. So given any triangle, side lengths A, B, and C, so you have side, side, side. The area of the triangle is this formula, and S is the sum of the sides divided by 2. Sum of the sides divided by 2. A plus B plus C divided by 2. Remember A, B, and C. So S times S minus the first side times S minus the second side times S minus the third side. So find the area of a triangle having side lengths. A is 43, 53, and 72. So we first have to find S. 43 plus 53 plus 72, and divide all that by 2. We get 84. So our area is the square root of 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. Square root 84 times 80. We have to use parentheses with this unless you do it in your head. 43 times 84 minus 53 times 84 minus 72. And if everything's correct, A should be 1131.9 square meters. Okay, there, not far. Pitcher's mound on the women's softball team is 43 feet from home plate, and the distance between the bases is 60 feet. How far is the pitcher's mound from first base? Well, I'm assuming that's a 45, 45, 90 triangle, right? So that's a square, so it should be 43 feet. But we can confirm that. We have side, angle, side. So H is going to be the square root of, we're using the law of cosines, side, angle, side. 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45. We better be getting 43 from that. So 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45. Okay, 42.4. Pretty close. Not perfect. I guess that's not right in the center necessarily. Don't know if the picture's mounted right there in the center. Ship travels due east, 60 miles due east, and adjusts its course northward as shown in figure 13.14. After traveling 80 miles in that direction, the ship is 130 miles from its side. Notice 3 different figures. Describe the bearing from point B to point C. Okay, so we have 60, we have 80, we have 139. We want to know this angle, and then we can figure out the bearing. Bearing is north, so many degrees east. Okay. So if I'm looking for this one, if I'm looking for B, I'm going to use, I have side, side, side. I'm going to use the inverse cosine of the two sides, 60 squared. I still have it here. I'm not having this memorized. It's, oh, there you go. You can see it. It's right here in front of me. 60 squared plus the 2 on either side, 80 squared, minus the one opposite, minus 139 squared, over 2 times 60 times 80. Inverse cosine, 60 squared plus, oh, okay, need another line, do the top, 60 squared plus 80 squared, minus 139 squared divided by 2 times 60 times 80. Okay, so that angle is 166.15. So let's just keep it 166. So if I'm going due north, this one's heading straight east, and then we're going up, and we know this angle is 166. So this part right here is 90. If I take 166 minus the 90, I'll get 76. Right? Yeah. So that means this right here is 76 degrees. So that bearing would be north 76 degrees east. Or 076 if we want a heading. Okay. That does it. Hopefully that answers any questions you have. Good luck. Stay Bluebird strong. Let me know what I can do to help. If you get stuck with anything, please message me. Let me know. And see you soon. Oop, where's my mouse? There it is. All right, there we go.